Hey, this is Mr. Mitchell, physical science teacher at Coosa High School. This particular video, we want to talk about scientific notation. Scientific notation is a way to simplify extreme numbers, and sometimes in science we're going to get some extreme numbers. For example, this figure right here, from what I remember, is the distance between the sun and the nearest star that is not in our solar system, and this is quite a few miles here. This particular number is a really, really small number. If I remember correctly, this is the amount of time it takes from light to get from one end of a bedroom to the other. Now, what's problematic especially is whenever you have extreme numbers and you then have to put them in formulas, because most calculators are not going to be built for this many zeros either before the decimal or after the decimal. So somebody created one time scientific notation, and that is an easier way to deal with big numbers and small numbers like this. So why don't we practice some scientific notation? We have, in this case, we're going to write it to where we have just one number to the left of the decimal. So we take the first numbers, and you see the first numbers are 2, 5, and 3. In fact, you take all the numbers when you have a lot of zeros, 2, 5, and 3, and you put a decimal right there where you have just one number to the left of it. And then you put times 10. From there, you count the decimal point. You see, the decimal point for this big number, as you know, is understood to be after the last zero. That's what happens whenever you have, well, big numbers bigger than 1. So you want to count how far it is from this point to where it would be right after the 2. So let's count. 1, 2, 3. You see what you're doing? 4, 5, 6. Every place, 7, 8, 9 is counted. 10, 11, 12, 13 to where it gets to where it says 2.53. So if you put the number of spaces you move the decimal right here, then that gives you your scientific notation. That big number over there is the same thing as saying 2.53 times 10 to the 13th. 13 here is called the exponent. You can see we have some numbers here. Decimal to the left, exponent goes up. In this case, we move the decimal to the left, and the exponent grew in number. We started at 0 and it ended at 13. So what do you do with a really, really small number like this? Well, you have the same principle. You're looking to write it where there is just one number to the left of the decimal point. In this case, it is 2.03, and you'll put times 10 to something power. So let's count the decimal. Remember, in this case, we're going to the right. Decimal is going to right, so the exponent is going to go down, which means you will have a negative number. So -1, 2, 3, -4, -5, -6, -7, -8. So the exponent here would be a -8. Don't put it as +8, because if it's +8, the decimal would go to the other side and you would have a really big number. So yes, you can simplify extreme numbers using scientific notation. So let's take a look at some practice you can have. Now notice we have 2 of them, number 1 and 2, which are just like the practice problems we had before. They're in what's called standard notation. That's how you would normally write a number. But number 3 and 4, we're going to start with scientific notation and then try to get it back to standard notation. So let's go with these practices. Let's go with here. So you know we're going to want just one number to the left of the decimal point. So you will write all those digits there that are not 0. And now we will put times 10, and we're going to count the decimal places moved. So you'll start here, and you'll just count. Now we're kind of lucky because with the commas you have groups of 3. So that is 1, 2, 3. That is 4, 5, 6. That is 7, 8, and 9. So you could even have looked at that and done that in your head, but it's always good to count. So this number is the same as 3.749 times 10 to the 9th. The 9 is the exponent. Remember, decimal to the left, the exponent goes up. You have a bigger decimal. Ooh, here you're going to have to go the decimal to the right. Let's see what it turns out to be. You know you're going to have 4.1, because those are the digits, non-zero digits that are remaining, times 10 to something. So that something will be determined on the decimal. And remember, when decimal goes to the right, the number exponent goes down. So this will be a negative number. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11. So that would be 4.1 times 10 to the -11th power, and that would be the scientific notation there. Okay, let's give these a shot. Here we have what is already in scientific notation. We want to go to standard notation. So we will write down the 2, 1, 3, and you know we're going to have to write zeros. So we want the exponent now to go down to 0. So we're going to move it 3 places back. So if we want it to go down, we're going to move the decimal to the right. Remember, if the decimal goes to the right, the exponent goes down. If the decimal goes to the left, the exponent goes up. So it starts here after the 2. 1, 2. Now we don't have any left. This is where we have to add zeros. 3. I'll add a 0. So that means this number right here is 2130, which looks to me like 2,130. No units on these particular things. So now let's try this. You may recall if the decimal goes to the right, the exponent goes down. Now this time we want the exponent to go up to 0. So we're going to move the decimal another direction. But you know 7.5 is going to be in it, and the decimal is right between it. So instead of moving it to the right, we're going to move the decimal to the left, and it'll be 4 places to the left. So 1, 2, I'll go ahead and put the 0 there, 3, I'll put the 0 there, and 4, put the 0 there, and that's where I'm going to put the decimal. So whenever you have 7.5 times 10 to the -4th, it is actually this 0.00075 is how you would read that out. So I have a bunch of practice problems where you can try scientific standard notation moving back and forth at tinyurl.com/Y2A4OZAD, and I hope this was helpful.